this is the second video in the playlist where we're actually looking through the sample assessment materials, and it's the higher tier paper from Edexcel. If you follow the link below in the description, you'll be able to download this paper. The whole idea is that we're going to be videoing for about 20 to 30 minutes or so, and that'll give you the opportunity to stop the video at each of the different problems, have a go at it, and then compare your solution with the one that I work out for you. I hope it's going to be okay for you. Please do have a look at the previous video in the playlist. Just make sure that you cover all the bases and you practice all of the different questions. Okay, so for this particular one now, we're going to be looking at question 9 onwards, and this is a fairly standard form type question. The easiest way of doing this is actually to separate the calculation, so I'm going to get 9 times 3 from the actual standard form itself, and you can see here what I've done is I've separated those up to 9 times 3, which is going to be 27, and then the standard form element of it is 10 to the power of minus 4 times 10 to the power of 7. Well, if you're multiplying indices, you add the two together, so that's going to be 10 to the power of 3. Now you'll notice that this is actually a 2-mark question. The reason being is that this will give you 1 mark, however it's not strictly speaking in standard form. What you need to do is make sure that the first number is between 1 and 9. In this particular case it's 2, and then comes the decimal point, and then the actual number of places that you've moved the decimal point would be 10 to the power of 4, and that would be the answer to this particular question. Okay, so the next question then deals with 64 to the power of a half. Well, that's just really a shortcut for saying the square root of 64. So in which case the square root of 64 is actually 8. So you would write 8 in there. Okay, and then the next one. So this is where it does get a little bit trickier, where I've got this find the value of this particular fraction. Now the important thing is that it's a minus indice here. So if that is the case, then actually the easiest way of dealing with it is just simply to flip it around, because all the minus does is basically tell you that it's the reciprocal. So if I flip that around the other way, I've got 125 over 8. Okay, now the next thing with it is to recognise that actually this 2/3 is the same as saying to the power of a third and then squared, because 1/3 times 2 is 2/3. Okay, so I've dealt with the minus because I've flipped it around. I've also now separated out this fraction here to be 1/3 times 2 rather than 2/3, and that means, as we did before in the previous question, you need to recognise that 125 to the power of a third is the same as saying the cube root of 125. Well, the cube root of 125 is actually 5, okay, because 5 times 5 times 5 is 125. Okay, the cube root of 8 is also 2, because 2 times 2 is 4, times 2 again is 8. So that deals with really this power of a third. It's the cube root of each of these numbers. And then we just simply need to square them. Okay, so 5 squared is going to be 25. And 2 squared is going to be 4. So my final answer will be 25 over 4. Some people might prefer to write it as a mixed number, and if you do that, that's perfectly fine. You can write it out as 6 1/4 if you wanted to. I don't think there's any more marks if you do. Okay, so I hope that's been okay for you. Let's have a look then at question 11. I am keeping note of the time here. We're about 4 minutes into the video, so I've got a little bit of time to work through, but I would suggest that you do try to stop the video, have a go at some of these questions and work through them for yourself. Okay, so 1 uranium atom has a mass of that. Work out an estimate for the number of uranium atoms in 1,000 kilograms. Well, basically, what we're saying, 1 kilogram. What we're basically saying is that this is 1,000 grams. So the real question here is how many lots of 3.95 times 10 to the power of minus 22. Are there in 1,000? It's so saying 1,000 divided by 3.95. Now it's going to be very, very difficult to do that. However, it is made a bit simpler because they've asked for an estimate. So I'm not going to worry about 3.95. I'm actually going to change that to 4. So I'm going to say, really, I can change this a couple of times. That 1,000, I'm going to change to 1 times 10 to the power of 3. Okay, and then I'm going to divide. Now in this particular case, just for the sake of this video, I'm going to write this as a division sign, even though it's interchangeable with the fraction sign here. And then rather than writing 3.95, I'm going to write 4 times 10 to the power of minus 22. And like we did before in the other standard form question, it makes it a little bit easier if you actually take the two numbers together and then work out the standard form element of it. Okay, so that would be like that. So let's just have a look at that for a minute. I've got 1 divided by 4. Well, 1 divided by 4 is the same as saying in decimal 0.25. I could write it as a quarter, but standard form generally tends to deal with decimals, so 0.25 would be correct for this particular one. And then I've got 10 to the 3 divided by 10 to the power of minus 22. Now you will remember that when you're dividing indices, you need to minus the 2. So I've got 3 minus 22. Well, minus and a minus together is going to give me a plus, so it becomes 3 plus 22, so that's going to give me 10 to the power of 25. Okay, that would give you probably 2 marks for that particular question. However, as noticed before, it's not strictly speaking in standard form. You need to make the first number between 1 and 9, so that would be then 10 to the power of 24 because I've moved the decimal point back 1 place. Okay, I hope that's all right for you. It does take a little bit of time to work through. It would be very difficult if you were trying to do this as 3.95, but if you do it as 4, then it's relatively straightforward. And it also means that, is it an underestimate or an overestimate? Well, it's an underestimate because what I've done is I've rounded up, which means that effectively I've divided a bigger number rather than a smaller number. So if I divide a bigger number, I'm going to get a smaller answer. Okay, so it's rounded up to 1 divided by 4, which is bigger than which is smaller than 1 divided by 1.39, 1 over 3.95. Okay, I hope that's all right, so I can just write something like that if I wanted to. Okay, hope that's all right for you. Let's look at question 12. Now, question 12 is a little bit trickier. I thought when I first looked at this question it was going to be fairly straightforward, but they've been a little bit sneaky with us because what they've done is they've given us an area of 60 centimetres squared. Okay, we're going to look at that for a moment. We're being asked to find the pressure exerted by a force of 900 newtons on an area of 60 centimetres squared, but you need to give your answer in meters, newtons per metre squared, and that's where it becomes a little bit more difficult. So let's just have a look at that for a moment. If I have a look at the information they've given us, they've actually given us a 60 centimetres squared. Well, what they want is something which is 1 metre square. Okay, now 1 metre squared is the same as saying 100 centimetres times 100 centimetres. Okay, so in other words, 1 metre square is the same as saying 10,000 centimetres square. It's important, it's 100 times 100. So it's 10,000, of which actually, unfortunately, they've only given us 60 of them. So what they've given us is 60 out of 10,000. Okay, so we really need 10,000 centimetres squared, but they've only given us 60 of them. So we just need to change this into a decimal and then use the decimal equivalent of that in terms of the area underneath. So if I knock off the zeros and then I'm going to move my decimal point 3 places back, so this is going to become 0.006. Okay, so that's the equivalent, if you like, of area which I've got. And I need to, that gives me the ability to convert that then to a metre square answer. So I then have pressure equals force over area. Well, the force is going to be 900 and the area is 0.006. Okay, so again, a little bit trickier, but if you move the decimal point around with these sorts of questions, it does make a bit more sense. So I can end up with, if I move this once, twice, 3 times there, 3 times at the top, I end up with 900 and then 3 more zeros divided by 6. Well, 6 into 900 is 150, so that's 150,000. And you can do that calculation by short division if you wanted to. So that's going to give us an answer of 150,000 newtons per metre squared, and that's the important thing with this type of question. Okay, I hope that's been all right. Please do stop the video, have a look at all of these and see if you can work it out for yourself. All right, so the next one is on to question 13. Now 13 again is a little bit trickier, just needs a little bit of working through. So what they've done is they've said, well, actually we've got this very large rectangle which is 10 by 4 centimetres, okay, and then we've got this smaller rectangle which is 4, and in this particular case it's here, I'm going to write x. So in other words, we've got this linear relationship we can look at, that how much bigger is 4 to get to 10? Well, it's actually 4 times 2.5. It's 2.5 times bigger. Okay, so this linear relationship here is a multiplication. They call it a scale factor of 2.5. So in other words, if we want to be able to figure out this value of x, what we need to do is divide this 4 by 2.5. So x is going to be equal to 4 divided by 2.5. Now there's a couple of different ways you can do that. If you want, you can do some short division, or you can do some equivalent fraction or something like that. What I'm going to do is, rather than writing 2.5, I'm just going to make it a little bit easier on myself and make it a fraction of 10 over 4. Okay, and that's just the kind of, I have a little bit more confidence in dealing with fractions, but that fraction is exactly the same as 2.5 as a decimal. Okay, well, I know that if I'm dividing by a fraction, what I'm going to do is I need to just multiply and flip over the other way. So that becomes 4 times 4 is 16, and 16 divided by 10 is equal to 1.6. Okay, so I now know that x in this particular diagram is going to be 1.6 centimetres. So if I want to work out the area, it's going to be 1.6 times 4, and I just need to do a very short calculation for that. I can do that over here somewhere, so that's going to be 16 times 4, and if I work that through, it becomes 6.4, but I remember that I've also moved the decimal point 1 place, so I'm going to make it 6.4. So the area in this particular question is going to be 6.4 centimetres squared, and that would be the answer to this question. Okay, so I hope that's been okay for you. Let's have a look then at question number 14. Now these questions are becoming very popular within these sorts of papers. Boxplots seem to be quite an area that you need to become proficient at, so just please have a go at boxplots, make sure that you're okay with them. So the first thing is that we need to draw a box plot from this piece of information. Well, with a box plot, the 4 key pieces of information you need to know is you need to know the lowest value and the highest value, and they call that the range. So this is going to be 17 to 20. 28. And then you also need to know the median value, which is this value in the middle. And then if you halve all the values in here, what you'll find is that the lower quartile value is 18 and the upper quartile value is going to be, in this case, 26. Okay, so I've got all the information that I need in order to draw my box plot. And probably the hardest thing to do with these sorts of questions is actually set the grid up in a way that kind of works. But what you will find is that usually they'll make it a little bit easier for you to be able to plot something that looks a reasonable size. And in this case, what I can do is I know that the smallest number I'm going to have to deal with is 17, so that's fine, and the largest number I'm going to deal with is 28, so that's fine as well. So let's just plot that in. I've got 15. Each of these is going to be a value of 2, so I've got 15, 16. No, it's not a value of 4, beg your pardon. 16, and that's going to be there, so that's going to be a value there. 28 is going to be back here somewhere. Okay, there we go. The median value is going to be 22, which I think I looked at before, so that's going to be 21, that's going to be 22. Okay, about there. Now I appreciate that this is probably not as accurate as it really needs to be. It's just a case of having to draw this very quickly in terms of the video, so it just makes it a little bit more difficult. But I can draw in there the lower quartile, and then the upper quartile is going to be 26, which is about there. Okay, and if I join up all of these lines, I get something like that. It's really not very tidy, but hopefully you'll get the general idea. And if you spend a bit of time doing that, it's worth 3 marks to you, so it's well worthwhile having a go. Okay, on to the next bit. Now, we've got all the information for Ben playing his 15 games of basketball, so have a look at Sam playing his 15 games of basketball. So what we're going to do is just, I think it would be easier with these for 2 marks just to draw a little bit of a comparison. So we've got Ben and we've got Sam, and the information we've got from the first box plot is that the median value for Ben is going to be 22 and the median value for Sam, according to the information we've got, is 23. So that's pretty much bang on there. Okay, the IQ range, the interquartile range for Sam is going to be 12, and the interquartile range for Ben is going to be 8. It's actually the difference between the lower quartile here, sorry, beg your pardon, the lower quartile here and the upper quartile here, and that's actually 8. Okay, so that indicates that he's a little bit more consistent. If we look at his range overall, okay, Ben has got a range of 11 and Sam has got a range of 20, okay, and the 20 I've taken from the information, and the range for Ben I've taken from the box plot along the top here, so from here over to here. Okay, so I would say in this particular case that Ben is more consistent. Okay, and just again for the sake of the video, what I'm going to do is I'm just going to point to these values along here because these are the ones that are important to make it consistent. Okay, I hope that's okay for you. So we'll have a look then at question 15. Okay, so let's just go on to question 15. And 15 probably, I think on this particular occasion, this will be the last question I'm going to do on this particular video, and then we'll follow up the rest when we get on to the final video, I think, in this particular playlist. And the videos are a little bit more sophisticated, you can tell, as we're moving through these things. Okay, so in a shop, all normal prices are reduced by 20% to give the sale price of a TV set is then reduced. Right, so the important thing is then reduced by 30%. Okay, so Mary says that it means it's a 50% reduction. Is Mary right? Well, no, she's not actually, because you can imagine what we've done is you can look at the first sort of incident where the rate has been reduced by 20%. So in other words, the sale price initially is going to be the same as saying 0.8 of the normal price, okay, which is a 20% reduction. All I've done is I've changed that then to a percent, a decimal. Okay, so from the 0.8 of the normal price, a 20% reduction, okay, means that what you actually pay in the sale is going to be, if you like, 80% of the normal price. It's then a further reduction, and that further reduction is then going to be 0.7. So in other words, this reduction of 30%, so 70%, but it's going to be 70% of the sale price, 0.8 times the normal. Okay, so what you've actually got at the end of it is, if we look at how we multiply that out, is 0.7 times 0.8. So that's actually the same as saying 0.56 of the normal price. Okay, which really then is the same equivalent to a 44% reduction, not a 50% reduction. Okay, I hope that's all right for you. Okay, so that's coming up to 20 minutes. I'm going to stop the video at this particular point. I hope that you've been able to work through these. Please do have a look at the playlist for the next video. I'm assuming it's going to be the last one. I'm not quite so sure, but we'll see. Please do add a comment below if you're not sure about anything. Always come back to you, subscribe to the channel, and I'll look forward to seeing you inside the next video.